The binomial distribution is a discrete probability distribution with n trials, and each trial can either result in success or failure. The normal distribution is a very good approximation of the binomial distribution as long as two conditions are met. The first condition is that the number of trials multiplied by the probability of success gets an answer greater than 5. The second requirement is that the number of trials multiplied by the probability of failure is greater than 5. This just ensures that enough trials were run to provide sufficient data. In order to use a normal distribution to model a binomial distribution, you can approximate the mean by just simply using n times p, and you can approximate the standard deviation by taking the square root of n times p times q. If we roll a 6-sided die 50 times, what is the probability of rolling a 6 more than 10 times? So in this case, success would be rolling a 6, and failure would be not rolling a 6. So since we're using a 6-sided die, the probability of rolling a 6 is 1 in 6. So the probability of failure would be 5 out of 6. And in the question, we're told that we're rolling the die 50 times, so that means n is 50. So this is a binomial distribution, and I want to know if I'm able to use a normal distribution to approximate this relationship. So if I calculate n times p, I get about 8.33, and n times q is about 41.67. Both of those are much greater than 5, which means we can use the normal distribution to model this data. In the question, we're asked, what is the probability of rolling a 6 more than 10 times? This means 11 counts, but 10 does not. So if we wish to make a range, then a value of 10.5 will be sufficient. So we're looking for the probability that x is greater than 10.5. But remember, when we use our z-score tables eventually, we're always looking for the value being less than a number. So I'm going to rewrite this as 1 minus the probability that x is less than 10.5. If you'll recall, the z-score is calculated by taking the x value minus the mean and dividing that by the standard deviation. And the mean is approximated by n times p for a binomial distribution, which in our case is about 8.33, and the standard deviation is approximated by the square root of n times p times q, which for this example is about 2.64. So I can use this to change my x value into a z-score. So when x is less than 10.5, that means the z value is less than 0.82. And when I look that up on my z-score table, I get an area of 0.7939. So when I do the math, I get 0.2061. So that means there is a 20.61% probability of rolling a 6 more than 10 times.